Are you cold?
A little bit. I think the thermostat's at 80.
80?
Yeah, but I think it basically either blows cold air or does nothing, so.
We had the same dress. I know. I ordered a different one, and then it literally didn't come. Never came. And I was like, are you serious? It fell out my nose. So then I was like, I ordered one, and I found it, and I was like, I'm just gonna order it. And I was like, oh, it's not I'm gonna copy it. And yeah, I was like, oh, I love it. That's so good. I love it. But I got it from my college. I was like, no, it was like, there's a lot of things to it. It was literally so pretty. So
All right, you guys will need a blank piece of paper today, and you should number your handout. Three of those. 2, 3.
Mr. Johnson, do we know how soon grades are going to be put in from the test?
We have to wait for Miss Cross to finish testing and grade her raw score so that we can officially agree on the curve.
Okay.
Pretty sure we know what it's going to be, but it'll definitely be by the end of the week, but it probably will be on the later side. So.
Okay.
I feel targeted by the meme today, which is kind of.
Yep, I was thinking of you when I did that one.
Oh, that's nice. That you think of me when I'm not around.
You're welcome. All right, we are moving into Unit 3. So remember, Unit 1 was a short couple weeks on limits. Then we have spent quite a while, several weeks, on the basics of derivatives, how to take a derivative, how to use your calculator to take a derivative, start to understand what a derivative means. We've seen a few applications like position to velocity to acceleration, but there are quite a few more. In this section, Unit 3, we don't spend very long in here because it's really two big ideas. It's implicit differentiation, which we're going to talk about today, and then something called related rates. Both of these are really just chain rule applications. They're not going to necessarily be super obvious that they look like chain rule to you, but they are just an application of that. And the related rate ones that we'll get to another class period, you can see have a lot of real world application. In fact, that's basically all they are. But for us today, we're going to look at implicit. So we're going to talk about these notes. Then in class, I'd like you to do a Khan Academy where you practice it a few times. And then finally, we'll move into a book assignment. And then that will be pretty much all the practice you need for implicit. Other than practicing a little bit, it's really just one step that looks a little bit different. So at the top of our notes here this morning, we've got, if I wanted to take the derivative of this, right now, you only know how to do this explicitly. But sometimes it's not possible to do it explicitly. But I just want you to see that this is maybe what you would have done. You could take it, solve it for y equals. Then when you take the derivative of y, you're left with the derivative of y, dy dx, also known as y prime, same thing. And then to take the derivative of the right, looks like they did the power rule, brought the power down, lowered the power by 1. They multiplied by the derivative of the inside, which is chain rule, and then they simplified their answer. This is what you're used to doing. But to show you a second way to work this question, and you'll see a lot of these, just this is not possible, we can do this implicitly. So instead of solving it for y equals, we're just going to take the derivative as is. Now, one thing that you guys need to be aware of is when we take the derivative of something like x squared, there's actually a piece here that I've not talked about because it hasn't been needed until today. But what is the derivative of x squared?
2x.
Okay. And then technically, x is like the inside. That's something being squared. So chain rule says if I take the derivative of the inside, so I'm going to take the derivative of x with respect to x. That's how that reads. And this doesn't really work like a fraction, or it's not really the exact same thing as a fraction, but it works out the same way. Something divided by itself is like 1, and because that's 1, we have not needed to talk about that yet. That's going to change today. So, same exact question, but they took the derivative of y to the third. So notice they brought the power down, lowered the power by 1, but this that I'm highlighting, it's really just chain rule, but again, the inside is y, so we just took the derivative of y with respect to x. When I say with respect to x, x is just the independent variable. It's like the main variable that we're using. When we take the derivative of x squared, you bring the power down, lower the power by 1, and then I just took the derivative of x with respect to x. Well, the derivative of x with respect to x, you can think of this as 1. Anything divided by itself is 1. Multiplying by 1 doesn't change anything, which is why we've not had to talk about it. But dy dx, this is the rate of change of y with respect to x. We absolutely must keep up with it. And in fact, if we're trying to find the derivative, that is the derivative. dy over dx is the derivative. So then algebraically, they subtracted this over, divided both sides by 3y squared, plugged back in for y, and you can see that they ended up with the same answer. Now, I don't know that this first example is really the best example because I think this on the left is a little bit easier, but you're going to see that this on the right is needed a lot of the times. So the highlighted steps here, honestly, is the one new thing we have to consider in these questions.
Wait, I have a question.
Yep.
How did it get from 3y squared to 3 times 1 minus x squared?
If, just like a lot of times we want only x's left in the answer, and this had a y left in the answer, so what they did, without showing it, is they solved this for y equals, it's right here, and then they plugged that mess in for y.
Okay.
So then it's only in terms of x. But we'll see some examples of that. Okay, so example 2. And I will let some of this be optional after this first example, but for the first one we got to be very careful here. So derivative of x squared is what? 2x. And for now, let's put dx over dx. I just took the derivative of an x with respect to x. Okay, the derivative of 5x would be 5. Once again, I'm taking the derivative of x with respect to x. Now, for us to use the same old power rule, quotient rule, product rule, all the stuff we've been practicing, you can do power rule like this, and you're going to get minus 8y. But this time, I took the derivative of y with respect to x. I'm highlighting that because that's the important piece here. Okay, what's the derivative of 3y? Only 3?
3 dy over dx.
Right, once again, I took the derivative of y with respect to x. It's like y is the inside piece, and you got to consider taking the derivative of the inside. The derivative of a constant is 0, derivative of a constant is 0. Now, most of this just goes away. dx over dx is like 1. So really, this stuff is just like 2x. This is like 5. But these dy's are important. And if you forget one of them, or both of them, then you're going to have some issues. Now, if you forget both of them, it's going to be pretty obvious because this is what we're trying to solve for. We are trying to find dy dx. Now, remember, dy over dx is the same thing as y prime. So I don't know. I tend to do y prime instead just because I think it looks a little cleaner, but it means the same thing. So really the only new calculus piece is when you take the derivative of a different variable, you have to include the, like y prime. You take the derivative of y, you need a y prime. Derivative of y, y prime. Otherwise it works out the same way. Now, if I want to solve for y prime here, the rest is just algebra. This stuff could be subtracted over. Subtract your 2x over, subtract your 5 over. Both of these have a y prime, so we could factor it out as a GCF, and then we could undo times with divide. Even though I'm going over those algebra steps pretty quickly, most of these questions will finish the same way. Move all the non-y prime stuff over to the other side, factor out a y prime, and then undo times with divide. Okay, moving over to example 3, or down to example 3. So if I just want to know the derivative of x squared, it's 2x, and then at least on this side of the worksheet, put dx over dx. I'm taking the derivative of x, that's the variable here, and with respect to x, minus 5 times x times y. Well, unfortunately, this is something times something. So product rule doesn't go away. We still have to take the derivative using product rule. So the derivative of x would be 1 dx dx with y left alone, plus, and then x left alone, and the derivative of y. What is the derivative of y going to look like? Okay, or 1. I'm going to put a 1 there. dy dx. I'm going to highlight that because that is the implicit step. Okay, what about this one? 3y squared, its derivative would become what?
6y.
Okay, and the dy over dx. And you can't just take the derivative of the left side without taking the derivative of the right side. Derivative of 7 is 0. Again, this is kind of messy, and I'm not going to make you do these past this side of this worksheet. And dx over dx is like 1. So I've got 2x times 1. I'm going to distribute this negative 5. It's like negative 5 times y and negative 5 times x dy dx. Again, I'm just making it look like y prime. Y prime and dy dx are the same thing. Plus 6y y prime. There was 2 times I took the derivative of y with respect to x. So there's 2 times I need a dy dx or a y prime. Now, if the purpose of this question is to find the derivative, I need to go all the way down until I know what y prime is equal to. But this stuff can be subtracted over. The derivative of 7 becomes 0. So anything without a y prime could be added to the other side. Now everything on the left has a y prime, so we can factor that GCF out. And then undo times with divide. Basically finishes the same way. So it's very similar algebra steps as the other one. The highlighted steps are the parts you just have to train yourself to consider. Taking the derivative of y can just be like taking the derivative of x. But you have to remember there's a y prime left behind. Okay, let me do 2 more examples for you, and then I will have you try one and see if there's any quick feedback you have. So I'm going to take the derivative of x to the third the same way I've been doing. But in my head, I'm realizing I'm taking the derivative of x with respect to x. I'm going to take the derivative of y to the third with the same old power rule, except this time I realized I'm taking the derivative of y with respect to x, and the derivative of the constant is still 0. dx over dx is like 1, but dy over dx is probably not 1. So we have to keep up with that. And in fact, if you forget it in this question, you're going to know something's wrong, because this is what we're solving for. We're trying to solve for the derivative here. That's the calculus step. I could subtract this over and divide both sides by this. And I guess you could reduce it maybe if you needed to. It's not that this implicit step is not hard, but it's kind of like chain rule, where you have to force yourself to consider it. Anytime we take the derivative of any variable other than what we're taking it with respect to, all of these will be with respect to x. We need that y prime left behind. Okay, one more example. This one is at a point, so slightly different question type, but same process. So the derivative of y, just like the derivative of x, would be 1. But I took the derivative of y with respect to x, so I must have that behind there. Minus 3 times, well, the derivative of x squared y, unfortunately, was going to have to be product rule. So x squared times y. So the derivative of x squared with y left alone plus x squared left alone times the derivative of y. Once again, I took the derivative of y, so I need another y prime, or another dy dx, same thing. So it looks like I have a y prime minus, if we distribute this, we've got minus 6xy, and if I distribute this, minus 3x squared y prime. Oh, I didn't do the other side. The derivative of cosine x would be, and this would be a dx over dx, because x was the variable. So now I guess what I want you to get out of this question is, I could add this over, I could factor out a y prime, I could undo times with divide, just like all those other ones simplified. But in this question, that's probably not necessary, because I know I really only care about when x is 0 and y is 1. Now, y prime is not the same thing as y. So y prime has to be left alone, but we can plug in a 0 for x and a 1 for y. It looks like most of this stuff just goes to 0, and we're left with y prime is equal to the opposite of the sign at 0. And what is the sign at 0? Zero. So I didn't have to solve it for y prime equals, or dy dx equals, because I was just going to plug in a number anyway. So typically just plug it in as soon as you have taken the derivative. It doesn't have to look nice before you plug the numbers in. Okay, any quick questions that jump out at you about number 6? Okay, then give it a shot. There's one on the top of the back page. I want you to try it before we discuss it together. You need to see where you might be going off. that long enough? Okay, so this eventually turned out to just be what? What's the derivative of 4x squared? Okay, 8x. And since it's dx over dx, we don't really need to include it. Do power rule here. And Ben, what'd you get on that? That's what you got?
Yeah.
Okay, well, I'm asking you because you didn't see there. And this is a common mistake. Don't put 17 here. If you're taking the derivative of the left side, you have to take the derivative of the right side. Just like all equations, you have to keep it balanced. This step, that's what you're this is the only thing new in this. Everybody got that? Okay, and then if you actually need to say what the derivative is, you can subtract this over, divide both sides by negative 18, and we can reduce it if we need to, but we've got the derivative. I'm sorry?
That's negative 18y.
Oh, negative 18. Thank you. Okay with that? Okay, before we move on to Khan Academy, where you got to get 4 in a row right, I do want to take a minute and have us look at, this is the first, I think this is a full FRQ as well. The first full FRQ we've looked at this year, because you have enough calculus under your belt where you guys can see what a real FRQ looks like. But the reason why I'm wanting to pull this up right now is this is often asked as part of an FRQ on the AP exam. And when they do this as an FRQ, they actually tell you what the answer is. They're saying, hey, the derivative is supposed to be this, and it's your job to show that that's true. So I think these questions are kind of nice because you know what you're aiming for. So let's go ahead and do part A here, and then we'll very, very briefly talk about B and C, just because it's good for y'all to see what you should be aiming for. Okay, so 2y to the third would be 6y squared and a y prime, because I'm taking the derivative of y with respect to x. The derivative of 6x squared y, you're going to have to use product rule. The derivative of x squared with y left alone, plus the derivative of y with x squared left alone. Once again, I took the derivative of y, so I need another y prime. The derivative of negative 12x squared would be negative 24x. The derivative of 6y would be 6y prime, because I'm taking the derivative of y with respect to some other variable. It's the third time. And then finally, the derivative of a constant on the other side should be 0. So 3 times I had to take the derivative of y. Here, here, and then from product rule here. So 3 times I took the derivative of y, so I need 3 y primes. All right, if we distribute this 6, just like on the other page, we still need to algebraically solve for y prime. What is y prime equal to? But it's usually got a lot of pattern to it. Basically, anything with the y prime, let's just leave it on this side. Anything that doesn't have a y prime, let's subtract it over. Because everything on the left has a y prime, we can factor out that GCF. We can undo times with divide. And since they gave us the answer to start off with, we need to compare and see what it looks like they did differently. How do I go from where I'm at to what they told me the answer was going to be?
Divide everything by 6.
Okay, so you could factor a GCF out of 6 out of the numerator, a GCF of 6 out of the denominator. Those could cancel. And then if I put this out front, divided by 6, that would be 4x. This divided by 6, that matches up with the numerator they told me to get. I lost an x squared. What happened to my x squared? Should have been an x squared here, which means there should be an x squared here, which means x squared here, x squared here, x squared
It should be only 6x in the middle of it.
Yes, it's 6y squared plus 6x squared plus 6.
6y squared plus 6x squared plus 6.
Pretty sure.
Okay, well, our job here is to show it, so I need to make sure my work is consistent. That moved over.
It looks like you added an x squared to the 6y prime. And from
Here?
the second step to the third step.
Here?
On the end
The variant.
of the second step.
Here?
Yeah, it looks like you added an x squared to the 6y prime.
Okay. I don't know. I don't see it, so I gotta do it over. You don't have to erase. Y'all can just correct when you see what it is, but I don't see it, so I'm just making the same mistake. Okay, distribute to 6. Anything that has a y prime, I'm going to leave it on the left side. Anything without a y prime, I'm going to subtract it over to the other side. I feel like this is looking better. Does that look like what y'all were saying?
Mhm.
Okay. Again, I just couldn't see it, and I didn't want to just pretend like it worked out, because the whole point of this, they've given us the answer, so the whole point is for us to show it, so I can't hide the work here. Divide everything by this mess. Don't skip any steps. Make sure you're showing what you're doing here, since that's the point of the question. And then if we divide everything by 6, and I could put this up front, that makes the numerator look good. Divide everything by 6 and put this one first. Okay, then it matches up. So that's pretty common thing for them to ask you to do on the FRQs. And as you will see in just a second, parts B and C, FRQs are definitely the hardest part of our AP exam. When they twist it and have you ask the question in a different way than you may have thought of it before, and it takes some more thought. It's nice that part of this FRQ is just do implicit and get to this answer. Show us that you can do that. Yeah.
Are we going to learn part B and C later on?
Well, in theory, you guys know how to do parts B and C. There's not any new calculus,
Yeah.
but I do want to talk about it as a group, but I also want to pull up the scoring guide real quick. Now, even though this is from 1998, and you might think that means it's not relevant, calculus does not change much. But this particular question, well, first off, this is an FRQ, so how many points is this possible out of?
6.
Nope.
That's a different class.
All our FRQs are out of how many points? They're all out of 9 points. This part A was worth 2 points. If you did the implicit, you get a point. And if your work showed that you did all of that right, you got a point. So there's 2 out of the 9 points for that. Now again, I don't want to focus on parts B and C too much here, other than I want y'all to see that they can be pretty tough, and they're not usually super straightforward, and it's something that we just have to work on throughout the year. But part B says, and again, I'm just going to go quickly, but y'all can just follow along. Write an equation of each horizontal tangent line to the curve. Well, when do you have a horizontal tangent line? When do you have a horizontal tangent line? Okay, what's another way to say the slope is 0? Okay, well, if you say that and you write it down, that was worth another point. Realizing that horizontal tangent lines have a slope of 0. So if you set the derivative equal to 0, you get a point.
Can we put y prime?
Same thing. Y prime and dy dx are completely interchangeable. So even though this is a tough one, they are fairly generous with the partial points, but you have to write down the step that goes through your head. So there was that. So to go about solving this, when does a fraction equal 0? Okay, wait, before we get into that. The only calculus part of part B is knowing that horizontal tangent lines is when the derivative is 0. But you guys have already heard that before. When does a fraction equal 0? Okay, and if you did that, okay, that's not quite worth it yet. This feels uncomfortable. You guys are not used to solving something that has 2 variables. But you could factor out a 2x. And now this looks like what you've done in algebra. If you have 0 is equal to x minus 4, x plus 4, you just set this equal to 0 to get an answer and set this equal to 0 and get an answer, right? So here, we can set this equal to 0 and solve, and set this equal to 0 and solve. So that would be 2. So when x is 0 and when y is 2, the derivative is 0. That's where the derivative equals 0. So if you got that far, and again, that's not something that you guys get to practice often, so it's understandable that you slow down and have to think about going from here to here. But it's definitely doable. I'm just looking at the point values. Okay. One of these, all right, it wants the equation of the horizontal tangent line. So I know when it occurs, but not the equation of those. So if you try to plug 0 into the original equation, you get something that looks like that. This, you can use the equation solver on your calculator, or you could graph it and find the x-intercepts like we did on that circuit that one day. This is true when x is about 0.165. You would need your calculator to solve that. Looks like that was worth the point. And then if you try to plug 2 into the original problem, oh, I'm sorry, this is supposed to be 2 in for y, 2 in for y. It looks like that. And what happens when I try to solve this? What should you do to try to solve this? No, I'm just trying to figure out what value of x. This is the easy part. Combine like terms. And you get an untrue statement. So that means you don't get anything out of that. But working through it and figuring out nothing comes out of y equals 2 is a point. And you got 1 point for working it out when x equals 0. So 4 points for part B. 1 just for showing that the derivative is supposed to be 0. That's when you get horizontal tangent lines. That's the parts you guys have to memorize and be quick to answer. Set the derivative equal to 0. A fraction only equals 0 when the numerator equals 0. The algebra is kind of messy here, but when x equals 0, you plug it into the function. You get an equation that needs to be solved with the calculator. That gives you a point. When y equals 2, you plug that into the original function. You're left with an untrue statement, so that doesn't give us anything else. But you get 1 point for working through and considering that. So 4 points for that. But again, this is not, using your calculator is not new to you. Solving an equation that doesn't have solutions is not new to you. The way this looks is a little bit different than maybe you had solved in algebra class, but none of this is really calculus. So again, I know that doesn't make it easy, but it does emphasize how you guys need to be really comfortable with the basics. Okay, and then the last part says the line through the origin with a slope of -1 is tangent to the curve at point P. Find the x and y coordinates of P. So when he says that the slope is -1, that also means what? Right, so you could set the derivative equal to -1. And based on how this one was set up, they told us the derivative. We don't even have to find derivative here. But we can't solve this yet. We can't solve an equation that has two unknowns like this unless it's a very specific case. So the fact that it said it went through the origin and has a slope of -1 means that we could make an equation of the tangent line. And so everywhere there's a y, we could instead put a -x. And if you do make that substitution, they gave you another point. And then to solve this, I would use my calculator again. You could multiply both sides by the denominator, but again, at some point I think you need a calculator to solve this anyway. So either through a graph or through equation solver, you should get x is -1/2. But it also asks for y. So if I know the x value, how am I supposed to find the y value? Plug the x value into what? That's going to give me slope, not a point. This is a point. So you got to plug it into the original function. So with the calculator, if you plugged -1/2 in for x into that original function, you would have something that only has y's in it. And then if you got your calculator to solve the y, it ends up being 1/2. And you got to do all of that for the 9th point. So a couple things here. One is, I need this to scare you a little bit because this is how hard the FRQs are, and they don't get easier unless we just practice them throughout the year. Second, I need you to see that there's very little calculus going on here, but if you don't know the calculus, then you are stuck. Even if you do know the calculus, it's kind of hard to figure out what they want you to do. But a lot of times, and I don't know the average on this particular one, but some of this stuff, like just setting the derivative equal to -1 or setting the derivative equal to 0, sometimes you get some points for that, even with no work to follow. But part A is the part I want you guys to focus on today. Of those 9 points, some of those are pretty tough, but 2 of the points came from implicit. So if we can get this under our belt, then there's a part of that we can feel pretty good about. So that's where we're aiming today. Again, I just wanted to go through B and C real quick, just so y'all can see the level, talk about how little calculus there is, let you see how difficult the algebra and calculator stuff can be. But is there any quick questions? Anything immediate about B or C that you want? Okay, then let us move on. So next up, I would like you to probably should put your blank work or your scratch work on number 37. There's just one Khan Academy that's only on implicit. So every time you take the derivative of y, put a y prime. So that part I'd like you to finish in class today, because you've got 50 minutes. And then the sooner you finish with that, you can practice a little bit more out of the booklet. As long as it's not the first 10 or last 10, then you don't need to ask. Okay, I'll give you a little bit of a head start, and then I'll come around to try to help on the questions you missed. You do need some scratch work on this, though. I don't think any of these Khan Academy questions should be super long, but it's way too much to manage in your head.
Oh, well, we just did in class, like, we did poetry. We don't know. The one from, wait, did you already do that one? Yeah. Oh, the three other ones. Oh, no, we're definitely gonna have to. I don't think I have it Wednesday. I don't think I have it today. Yeah, that's what she said. I think we're doing something else today. I'm writing stuff.
Also, you are welcome to use a calculator on this, but I don't think it's going to do much for you. It might help a tiny bit on questions where you need to plug in a point at the end, but and of course with the Khan Academy, when you miss one, don't just fly past it. Click the Get Help so you can see what you did differently. And then if you're still not sure, ask your neighbor or ask me as I come around.
Yeah. I'm just worried about that and really reflecting like stuff. I know you look like you do. Here you have to do product rule. It just ends up being now this is x times y. So you gotta do root of x is 1, so it's y left alone, so y plus x left alone times derivative of y to be xy prime. And then we can multiply them together, which
Why would you want to do that?
product rule from that side. I'm done.
Probably the hardest ones of these are the ones where you have to use the product rule. If you've got something times something, like an x times a y, you should have two terms. Derivative of x with y left alone, and then derivative of y with x left alone. I would say that's going to be the most common mistake.
Alright, well, it gives you a point. So, like, if you want to try to solve it for y prime, you can. But honestly, if you have a point, you can start plugging that stuff in.
What is it?
You're gonna see when x is 0, all that goes away. Is that an x? But that has an x. So when x is 0, all that goes away. Plug in -1 into the y's, and then solve for y prime.
I'm not saying that that's wrong to solve for y prime first, but it's just if necessary.
The ones with a point should be easier, because the simplifying is just not what we need.
And also this is one of two big topics in Unit 3. The other big topic in Unit 3 kind of has a similar thought process as far as the y prime stuff, so. Guess I'll start putting these in. Give me just a second to start putting, I'm gonna go ahead and start putting the Khan Academy grades in
I'm finished.
for people as they finish, and then I'll come around and help. And obviously, I'm willing to help you guys with the book questions as well, but let me get a chance to help everybody.
derivative of y here, let x alone, but then you put a y prime. But also, you said this is negative 5 times x times y. You would need negative 5 times all of that. And it looks like you only put it with the first part. That's right. Put that in.
And for those of you that have moved on to the book assignment, you may want to take notice that all of those questions are odd. So you should quickly be able to check your answers in the back of the book. I also have all of these worked out on the website. So if you don't get some of those in class, you can use that.
So you did the live. I don't have to take like, is there like 5 before that I should like?
Did you take the derivative of something with y in it?
I guess, yeah.
And you need a y prime.
Either y,
It's going to be either the y,
y prime.
y times a y prime. Now, if you weren't taking the
Wait.
derivative,
Either the y times y prime.
these are derivatives of either.
Okay.
Same format as e to the x, but you took the derivative of something with y in it, so you need a y prime. And you're welcome to use the same piece of paper for 37 and 38. But I do recommend, as you guys make mistakes on the Khan Academy and you get them figured out, highlight or circle the steps you missed so that you can look back at this piece of paper later and just review the things that didn't. Checking your answers? No? Okay. E to the y, y prime. Y prime. Just like e to the x is e to the x, e to the y is e to the y. But because it has a y in it, you need a y prime. No, it would be e to the x is e to the x, take the derivative of x with respect to x, so we just say e to the x. E to the y, so e to the y, but now I'm taking the derivative of a y with respect to an x, so we have to say e to the y, y prime.
Did I start 11 right? It's changed.
Sine, cosine, cosine something, negative sine something. Times the derivative of the inside, which would be 2, and then you're taking the derivative of y, so you're like, yep. And in that case, if you feel iffy about this y prime, I don't know. That's ultimately what you're solving for.
Yeah.
So without it, you don't have
Mr.
a derivative to solve.
Okay.
So I'm solving the derivative of this at the time. So now that I have the derivative, I know that I need to get the y's to be something x. Like, any
Just plug this in. Everywhere there's an x, plug in 0, and everywhere there's y, plug in -1.
Okay, so I'll do different between the x and 0. So it'd be 1 for y.
We'll plug -1 in for y's too.
Oh.
You got an x value to plug in and a y value to plug in.
So I can plug in both. So, over -4. So 1 for x.
Okay. And just so you know, like how you solve this for y prime, that's necessary sometimes. But since you have the point, you could have also just plugged in 0, -1 way up here. Because all that goes to 0, all that goes to 0, that goes to +1.
Yeah.
So it would have been a lot quicker to just solve it from there.
Okay.
Assuming your other stuff's right, that's all you have to do is plug those 2 points in, solve for y prime.
Okay, thank you.
I did the Khan Academy, Mr. County.
Okay, that's good.
What did you do this weekend?
I tried to think about what kind of weird questions you were going to ask me during class.
Oh, yeah. I don't ask weird questions.
This weekend, I don't know, laundry, made food, slept in,
Slept in until 6.
more laundry. No, I slept until 8:30 on Saturday.
Oh, okay.
Getting lazy.
Well, I also was probably asleep by 9 o'clock, so.
It was my grandpa's birthday yesterday.
It's fun.
So that way after home, we will complete the 1 p.m.
45%.
No.
more.
I don't know. I have a problem like this thing where I feel like I'm so late. Yeah, that is, but I know this thing that I get about it. So I'm like, stuff. And then the Sunday morning, I'm again. I was like, it's complicated.
On Saturday, I slept until 8. I never. I wasn't even doing anything. Like, I jumped up out of bed and I was like, sleeping. Nothing going on.
I went to bed at like 2 on Sunday morning. And woke up at 4.
PM?
No,
AM.
no, it was 6, but that was for church.
Oh, okay.
And then I didn't go back to sleep until last night. It stinks.
Still trying.
No. Yeah, you know.
Okay, still got about 27 minutes, I think, so. If you're gonna need help with the Khan Academy, you should be asking sooner rather than later. Those questions have videos on the website, so you can get help with those that way. Are you taking the burden of it?
Sing it for the audit for
Then yes, you
Oh,
know.
Y prime. Every time you take the derivative of y, you need a y prime. Also, right there on the board, it kind of worked out.
Oh, cool, okay.
See, this question's like,
Do I have to do audit school?
The derivative of sine something is cosine something, then chain rule, you have to do the derivative of the inside, which is product of it doesn't take that long. Derivative of x is 1 times y left alone plus x left alone times the derivative of y, which is y prime. See? You could have just done it in the time you asked me.
Well, I had to make sure I was gonna do it.
all I'm gonna say is I hate product rule, the burning passion.
Yeah?
It can go down a hole.
It's worse than quotient rule?
Some days,
No.
yes.
Yeah, I would think quotient rule would be worse, but.
Some days.
I would much rather do product than
Yeah.
quotient.
It's a lot.
I just copied it off my paper and I was happy. Well, so did, I did that
But yeah,
with social
it
too.
is. I did that right, so now this is my part, right?
Okay.
Oh, I gotta multiply.
You could distribute this,
Yeah.
get rid of your parentheses, move the y prime on one side, factor it out.
Your shelf eggs on the wrong folder.
You know, it's been that way for 10 years, so
And you haven't fixed it.
it's missing a piece. There's nothing to fix.
plans for this weekend?
This weekend, the one that's like a million days away.
It's only 4. And I'm already excited.
I've got way too much work between now and then to be worried about this weekend.
Yeah, but think of the outcome. 2 days of freedom.
2 days of rest. Maybe.
It's not even that hard, it's just more.
Times.
When the next, so yeah, so I was thinking, when I kind of was thinking, I was team the derivative of y as a part of it, so I was getting secant square of 1 times y. But that's not how it,
You got that?
yeah. Should be able to.
Also, just kind of a side note, in case you guys are wondering like what these equations might look like. Oops. Like something like this isn't a function, but like some of these equations would be for like circles or ellipses or other conics. So like if you were doing implicit to solve this, you're basically getting a formula that can tell you the slope of the tangent line for other things besides functions, things like circles. Sometimes we're interested in those rate of changes as well.
Why would we ever use this word here?
Well, because that's the only way to do it on some of these questions.
This, I think, calculus is in the first class to make me cry.
Well, then you did pretty good.
And then,
Also, along the same lines, I didn't mean to really get into this, but if you were working this question to have the slope of a circle, this is why your derivative probably has x's and y's in it, because like if you only know x, like x equals, if your derivative only had x values in it and you plugged in x equals 2, it wouldn't know if you were talking about this slope that's positive something or this slope that's negative something. That's why your derivative should have x's and y's in it now, because it matters. You need to know the x value and the y value. Does that make sense, what I'm saying there?
Yeah.
Having just x is not enough if it's not a function. You need x and y to know exactly where. Yep.
Good. Cosine something is negative sine of the something times the derivative of the inside, which would be 2 times the derivative of y, which would be 1, right? That looks fine. This kind of looks like 2 minus sine.
yes,
I know
let's do
it's
-2 sine.
yeah, just change this to a minus. And I don't know where your y prime is.
I haven't finished.
Okay.
What did you get for 7?
Okay, you should have a cosine x equals. Okay, well, did you distribute this or not? I did do this. Okay, so the product would be derivative x with this left one.
I did, I went straight to chain.
If you don't distribute that x, you're gonna have to do.
Okay.
Well, either way you have to, but if you don't distribute to x, you gotta look at the whole thing in the product rule. If you distribute to x, the first derivative is easy, but you still have to do product rule. So, I don't know.
That's even.
We have 15 minutes.
Got aside about 15 minutes. I would say in these 15 minutes, if it doesn't look like you will finish the book assignments, you might want to take a picture of the question page and maybe a picture of the answer page so that you could work on it in advisory, or if one of your other classes has a sub or something.
I'm puzzled because the answer does not even come close to what I got.
Okay, I gotta see the question.
Yeah, that's probably important. Number 9.
You did.
I did quotient, or I did product rule.
That was good. Minus 10. Wait, right here you took the derivative of y. So you need another y prime.
Oh, that.
Another y prime.
See, that makes things different. And I don't like anything different. I forgot about the really wise outside of
Well, if it wasn't different, then we wouldn't be spending class time on it. Doing okay? So you don't want me to just guess for you?
Is a y plus y. Or wait, plus x is y times y prime.
Yeah.
You know where I have these worked out on the website?
Yes.
I was gonna say, I'm fine if you ask me during class. You get the volume off, sometimes people just like to jump to the structure end, and then you're not waiting on me.
Did you do that?
Oh, I heard that. You're very loud, Christian.
Am I? Have you heard everything I said this class?
You project easily.
Well, that's protecting.
natural born leader. You
Well,
always
like
make
you
your
got it.
decisions.
You actually
You don't even need to product rule.
Well, I'd like to see how he does it, so I can do it.
2 times
myself
the
next time.
cosine of something.
Okay.
The derivative of that would be 2 times the negative cosine of something. Times the negative sine of something.
There's no point.
Negative sine, you check the derivative of y, so it's
You
there.
won't. Just keep pulling stuff out of there.
No.
Paper there.
Your friends can stay this way.
No. Why?
I just wonder, they keep sending me emails and I'm like, no.
Bro, so many
Oh, yeah.
college
See,
so
that's,
many
yeah,
emails
you're
and I
missing,
just.
the derivative of cosine.
I think it's just finger.
I'm not going to the close on this college to have this
Who
college.
was sending me
Times
stuff?
derivative of
Vanderbilt
y.
keeps sending me stuff. Did he keep sending me
The
stuff?
derivative of 2y would be 2y prime.
They're like, you don't reply. And I'm like, this would not. You guys are fake.
Like, when I get your books at Harvard, you're not like,
Yeah, like something about not letting me into your.
like this Columbia emails are getting my books.
Linda,
The derivative of 2y would be 2y prime.
Who? Holden? Yeah.
did you ever do that like big side? Oh,
Just the y minus y.
It's hard to see because you have it through there, but that's from something else, not from something.
Look at the note
Oh, I
sheet.
have.
Yeah.
Wait, for 11. Isn't it or is it? Is it product or entry?
No, it's just simple.
11? What did you just say? You're looking like 2 side, 2 y, and then inside is times
So it
times
just
2y.
2 what?
Okay, yeah. Wait. It would be negative 2 sign? Would you leave the 2?
What?
Would you leave the 2?
Yeah.
Okay, wait, why?
It does that, but just leave it to everything like.
Okay.
We plug in 0 to
Yes. And then we'll after we get that, we multiply that inside. Then multiply it by
I'm
2.
trying to think about more.
Yeah.
You're not gonna like it next week.
It's gonna be the front again.
At this rate, all by yourself.
I'm always in the front by myself.
Well, then you do your work. Go down and tell me.
I do that sometimes. Sometimes.
Do that sometimes.
Oh,
Or you make it a lot.
yeah, I mean, like, I did it 2 times y prime this already. And you times. Oh, why did you do that?
I really don't like doing questions.
0.
Well, it's that see. See, if I just cover this up for a second. This, the derivative of cosine something is negative sine something, right? Then to the change of order means a 2y prime. But then there's also the 2 that's already out there, which makes it become a 4y prime.
And you wouldn't take using that,
Just like the derivative of 5x squared is really the same as the derivative of x squared times 5. Just worry about the number out front later. I'm just gonna make it twice as big.
I created this particle and 0 times cosine 3y, so that cancels that out.
You could do that, but half of it goes away anyway, so.
Yeah.
And then you would do this left alone, 2, times the derivative of this, which is, ends up being the same thing. So it's not that product rule is wrong, it's just a little bit extra work, especially when half of it just goes away. Just mine or yours?
Am I on the right track with this?
Yes, but the way you're writing this, it looks like you want the sign of 2y, 2y something. Yeah, but,
Should I do that?
I would just put this in parentheses, just to,
This in parentheses?
because
Okay.
that's the only thing you're really taking this out.
Yeah, so can you explain why I kept the 2?
Well, I'll do, let's say, what's the derivative of this?
2x squared.
Okay. Or
Oh, is that
it's the same thing as, what's the derivative of x cubed?
3x squared?
It just makes it 2 times bigger.
Okay,
So if it's out front, just multiply by whatever the derivative
okay.
is.
Thank you.
Okay, so the derivative of sine is cosine. You need to make a decision whether you want to distribute that x or not.
That'd be, no.
Don't want to do x? Don't distribute it? Okay. Then you've got okay, so you're gonna have to do product rule here. We've got something times something. So the derivative of x would be 1 times this stuff left alone. Plus, then leave x alone times the derivative of this stuff,
What was your answer for
which would be 0. The derivative of tangent something is
negative cosine
squared of the something. But because we just took the derivative of something with a y, you need another y prime, or actually your first y prime.
0 doesn't change anything, so you can erase that.
So just try to change.
Is that a, oh,
What question is that?
And then you need to, I think that might be the only Y prime.
yes.
Yeah, so to distribute your X,
Oh, the set.
keep this Y prime stuff on one side and move everything else to the other side, and undo this time this by dividing the set. Okay. Unless there's a point. Does it give a point? No, that doesn't.
So that's a derivative of 2x. And the derivative of 3 natural number times 3 natural number times 1 over
So, 3 times, the derivative of natural log of something is going to be 1 over to something. So you need a 1 over y. You shouldn't have a natural log of y there. It sounds like you were trying to do like product rule.
chain rule. So you write natural log that would fit inside of the 3. That is it.
No, it's not.
Okay. Explains.
All right, we got just a few minutes here. So if you were unable to get 100% on the Khan Academies, you still have until the start of next class. And then there's 14 book questions total. Obviously, some of you had more time on that than others, but if you would please finish those, try those out. All of those are worked out as individual videos on my website, so whichever ones give you issues, watch those videos and help that complete the homework, please. And then next class we will talk about related rates.
Is the homework due next class?
Yes. It's homework for tonight, so I'm not going to give you homework on it multiple nights.
Oh, yeah, you signed me up for advisory. Except for Friday. I don't know what I'm going to do Friday.
Well, I can still put you in for Friday.
No, it'll be alright.